everyone, I hope you are doing well. Today I will be going over some of the science past paper 1, grade 11, 2018. It is the November paper. I'll be going over the first half of the paper. Question 1 is our multiple choice questions, and this is a very important question. Since it seems simple and easy because it's multiple choice, but often it is quite difficult, and since each question is worth 2 marks, it can quite heavily influence your results at the end. So let's go through this slowly and make sure we can understand everything that is being asked. So first we'll have question 1.1. In question 1.1, you are told that you have 2 forces, force 1 and force 2, and they're both acting on the same point. They tell you that if force 1 and force 2 act in the same direction, the maximum resultant has a magnitude of 13 newtons when they're in the same direction. Then they tell you if force 1 and force 2 act in opposite directions, the magnitude of the minimum resultant is 3 newtons in opposite directions. And then they ask you, what is the magnitude of the 2 forces in newtons? So how could we figure it out from this information we're given? Basically, what we have to do is in the same direction, our force 1 plus our force 2 is equaling 13. Here, force 1 minus force 2 is equaling 3. So we need to find 2 values of force 1 and then a value for force 2 that can give us this kind of result. So here you go through the options given. 8 and 5. So if we substitute in here 8 plus 5, 8 plus 5, you get 13. If you substitute in here 8 minus 5, you get 3. So already we know the answer is 1A. However, if you want to, just to cancel out any other options, if you were to substitute in B, you would have 16 plus 10, which is equal to 26. Already we know it's not right. And you can double check it by saying 16 minus 10 is giving us 6. Again, not correct. For answer C, you have 10 plus 3, which gives us 13, so that's right. But then if you said 10 minus 3, you would only get 7, and you need 3. So that would also not be correct. The last answer, answer D, gives us 10 and 7. 17 is not correct. 10 minus 7 is 3, which is correct. But you need both answers to be correct. So here we have a correct answer and a correct answer. But in order for the answer to be correct, you need both of them to be correct. I hope that makes sense. Now we move on to question 1.2. 1.2 says a free-moving block slides down an inclined plane at a constant velocity. So they have put constant velocity in capital letters to emphasize it. What does constant velocity mean? A, saying the frictional force acting on the block is 0. B, the net force acting on the block is in the direction of the slope of the plane. The net force acting on the block is 0, or the component of the weight parallel to the plane is greater than the frictional force. So let's break it down. What does constant velocity mean? Constant velocity means no acceleration is happening. This object is moving at the same speed. It's not getting faster and it's not going slower, which means no acceleration. So if we look at our formula, F net is equal to m times a. If our acceleration, we said, is equal to 0, then whatever our mass is, it doesn't matter. Anything times 0 gives us an F net of 0. Therefore, our answer here would be 1.2 C, because C said the net force acting on the block is 0. So if you look at this equation, you can see F net on the block is 0. So whenever something is traveling at a constant velocity or without acceleration, your net force is 0. It's not to say that there isn't any forces acting on the object. It's just to say that forces acting for the object and against the object are equal. And then you'll have constant velocity and no acceleration. All right, question 1.3. It now says that you have a trolley being pushed along a horizontal surface with a force of 150 newtons at an angle of 45 to the horizontal. So they've drawn you a little diagram here of your trolley, and it is being pushed with 150 newtons, but this 150 newtons is at an angle of 45 degrees. And then it tells you that the trolley is experiencing a frictional force of 60 newtons. So if we're pushing our trolley this way, friction is always against the direction of motion. So our friction is 60 newtons that way. All right, so now they ask you the net force acting on the trolley, and then they give you 3 options. It causes the trolley to accelerate horizontally, is equal to the applied force, or is horizontally forward. So you have 3 options and you need to choose which statements or which options are correct. So let's go through our options. The net force acting on the trolley causes the trolley to accelerate horizontally. So what does that mean? If our net force acting on this trolley is causing it to accelerate horizontally, we need a net force going in that direction. So how would we calculate what our net force is? So what we would have to do is we cannot take this 150 as our net force or as our applied force in this direction, because this 150 has a vertical and a horizontal component, right? It is going down and to the right. And we need to figure out the component, this horizontal component of it that is going to the right, and compare that value to this 60 going to the left of friction. And if we calculate those 2 forces, we would get our net force either to the right or left. If we have a net force to the right, we would have that it is accelerating to the right. If we have net force to the left, it would not be going anywhere because it's the friction. So we would not have it accelerating horizontally, which would prove question 1 incorrect. So here, how would we calculate our force here? Well, we know that this is our hypotenuse, this is our adjacent, and this is our opposite side. So we want to calculate our adjacent, and we have our hypotenuse. So what would we do? We would tell cos 45 degrees times 150, which would give us a value of 106. Our component here, let's do it like this, would be 106 newtons to the right. So we have a net force here then of 106 newtons minus our 60 of friction, and you would get a force of 46 newtons to the right. Therefore, statement I, saying that the trolley is accelerating horizontally, is correct. So I is correct. Now the second one, the net force is equal to the applied force. Well, that can't be right. Our net force is 46 and our applied force is 150. So we already know that I, or number 2, is incorrect. Our third statement is that the net force is horizontally forward. So if we take this right as forward, we do know that our net force is net to the right, which is net forward. So number 3 is also correct. So now we have to choose which option gives us these 2 as correct. Option 1 says that 1 and 2. So 1 and 2, no. B says 2 and 3, 2 and 3, no. C says 1 and 3. We know that 1 and 3 are both correct, so our answer here is 3. We can again check. D says 1, 2, and 3. 2 is not correct. Therefore, our answer is definitely 3C. Okay, we move on now to question 1.4. Question 1.4 says a man in a lift is moving upwards at a constant speed. So he's going up at a constant speed, therefore no acceleration. Remember, there should be some words that make you think immediately of something else. The weight of the man is W. According to Newton's third law, so what is Newton's third law? We need to remember that Newton's third law is that every force has an equal and opposite force. According to Newton's third law, the reaction force of the weight, W, is the force of, so you need to complete this sentence. So first of all, we need to figure out what force we're dealing with, and then switch it and use the opposite force, because they want the reaction force. So what is our force we are dealing with? The weight of the man. So the reaction force of the weight is the force of. So what is our weight? The force of our weight, which is our gravity force, is the force the Earth is exerting on a person. So the Earth for gravity or weight, right? Remember this always. The Earth on the person, or in this case, the man in the lift, is the force of gravity. So the Earth exerts a 9.8 meter per second force on the man. So now the reaction force, all you have to do is switch these two because they're equal and opposite. So the man on the Earth, he also exerts a force upwards on the Earth, while the Earth is exerting a downward force on the man. These will be of equal magnitude and, as you see, opposite direction. So 1.4, which answer do we have now? A, the floor on the man on the Earth. No. So the Earth on the man, no. The Earth on the man is our initial force. It is the force the Earth is exerting on the man, but they're asking for our reaction force. C, the man on the floor, no. The floor has nothing to do with the gravity. And D, the man on the Earth, which is exactly what we said. So 1.4, the correct answer is D. Remember to read very carefully here. Okay, 1.5. We are told that we are asked the optical density of a medium, and then fill in the rest of the sentence. So first, what is our optical density? Our optical density is the ability of a material to transmit light. So how well can a material let light pass through it, right? So now we know our definition. Let's read our options. If the optical density of a medium is high, the refraction will be less. Does that make any sense? Thinking about our definition, the ability to let light through. No. If our optical density is high, so if you have a material and it's got a high optical density, it's got a lot of squiggles versus a little bit of squiggles, light trying to pass through here will be less likely, it will refract more. So let's say I have three pieces of light trying to go through. 1, 2, 3, most of them will not get through. But if you had an optical density that was lower, maybe 2 of those would go through and only 1 would refract. So the statement A, the optical density of a medium is high, the refraction of light is less, is not true. If the optical density is high, you will have more light being refracted. It means more light will not be able to pass through if the optical density is higher. Okay, so A is incorrect. B, the optical density of a medium is a measure of the refracting power of the medium. Well, that makes sense because if the optical density is high, the refracting power is high. The optical density is low, the refracting power is low. Therefore, it makes sense that it is a measure of the refracting power. So that makes sense. Let's read on to see if the others are more correct. C says the optical density is less when light bends towards the normal when entering the medium. So basically, it is saying that when it enters, does it bend away from the normal or towards the normal? So if your optical density is high, the optical density is less when light bends towards the medium. So when it's less, it will bend away from our normal. So if our normal is straight and we have an object of a medium that is less, so a low density medium, your light will not necessarily bend towards the middle. It would bend away from the normal. So here's our normal here. And if it has a low density, it would not bend towards our middle. Therefore, C is not correct. D says if the optical density of a medium will be high if light moves faster through the medium, which is also not true. If we look at our formula, the optical density is not high if it moves faster. It would actually be low if it moves faster. The higher the density, the slower. Therefore, the only answer that made sense there would be B. So 1.5 is B. 1.6 now, we read that they ask that one of the graphs below represents the gradient of the refractive index of a material when light passes from the air to the material. So basically, light is going from air into a material, and they're asking you, what is the refractive index here? All of the graphs show us a directly proportional relationship. Directly proportional means increasing the y when your x increases. Directly proportional always looks like a straight line. So what are our options here? Our options are either theta I with theta r, or it's that swapped, or it's sine theta I over sine theta r. So they want you to figure out what is your x and what is your y. So how would we do this? What equation do we have to solve this? Well, we have Snell's law, which says that n of your I, your initial sine theta of your initial angle, is equal to nr, your refractive sine theta r. So now, how can we solve this? Well, we know that they tell you that it's going from air, and we know that the refractive index of air is basically 1. So this value is basically 1. So now we have sine theta I. And what are you trying to figure out? The refractive index of the material. So you're trying to figure out that. So how could you isolate that variable? Whenever you're trying to solve for something or figure something out, you need to isolate that variable. So how could you do that? You could divide both sides by sine r. So if you divide both sides by sine r, you would get sine theta r is equal to the refractive index of the material. So now if we think about this in terms of a graph, what is our top, or our gradient, what is our top value? Our gradient is change in y over change in x. So if this is our y, let's look at which graph makes this on the y-axis. The only graph that has sine theta initial as our y and sine theta r as our x is graph D. So for 1.6, we would have graph D. Then we move on to question 1.7. 1.7 gives us a statement and asks us for which statement this represents. Every point on a wave front acts as a point source of a spherical secondary wave that moves forward at the same speed as the wave. So they're giving you a definition, and they're asking you, what is this definition for? For science exams, it is extremely important to know your definitions off by heart. You should be able to recite them word for word and also understand them. So 1.7, there's not really an explanation. You should just know that 1.7 here is B. So that explanation that every point on a wave front acts as a point source of a spherical secondary wave that moves forward at the same speed of the wave, you have to know that that is Huygens principle. However, someone pronounce it, everyone has a different way. Huygens principle is that. So if they ever ask you what is the definition, you would have to be able to write that every point on a wave front acts as a point source of a spherical secondary wave that moves forward at the same speed of the wave. So study your definitions very, very well. Next is question 1.8. They tell you that there are 3 charges with a magnitude of 2 plus, or plus 2q, minus 2q, and plus 2q. And now they ask you which arrow correctly indicates the net force acting on the minus q charge. So what are we focusing on? We're focusing on this charge. Remember to read carefully and listen to what you are asked. This is the charge minus 2 that we are focused on. So what is happening to this charge? Well, these are opposites and these are opposites, right? So we know that the charge is attracted that way and the charge is attracted that way because opposites attract, likes repel. Opposites attract, so it is trying to go up, but it is also trying to go to the right. So where would it land up? It would land up going up and to the right. And since these charges are equal, it would be equal. It would be in the middle exactly, but that's not exactly what they're asking you. They just want to know the rough direction. And if you're looking at my arrow and you're looking at your answer sheet, my arrow coordinates with question 1A, 8A, sorry. Therefore, your answer here is A. Why would it not be B? Why? So B we have as down. Why would this charge go down? If it's attracted to the right and up, it would not. Why would it not be C? C is saying that it's attracted only to the right. But then what happened to this one? It is attracted upwards as well as to the right. And D says down. Again, it would only go down if it was repelled by that one, but since they are like charges, they are attracted. The only reasonable answer there would be A. 1.9 now says, which one of the sketches below represents the correct magnetic field pattern around a straight carrying conductor? So, when we see our straight current carrying conductor, which principle, which motion, which hand signal, and do we immediately think of? So our straight current carrying conductor is our right hand rule. Now, if we look at our graph, the first two make sense as our right hand current carrying rule. So it has the lines, neatly drawn, but our lines carrying a current in a direction with our thing in the middle. So if we do our right hand rule and we put ours on A, which has a circle in the middle, so with our thumbs pointing upwards, and we pretend to do this. In my sketch, we would be correct. But A says, with our dots, so our thumbs pointing up, our current's going to our magnetic field's going to the right. But if you do that with your hand, which direction are your fingers pointing? If your thumb is faced up on your right hand, you would have that your current is going left. Your current should be going that way. Your fingers are curling that way with your thumb faced up. So A cannot be correct. However, B, we have the same thing, same direction, but now we have an X in the middle. So if we now put our thumbs down onto our piece of paper or onto anything, our fingers are curling this way. And that agrees with what is drawn on the question. Here, therefore, our answer would be 1.9b. Then we move on to our last multiple choice, 1.10. It asks us which one of the graphs below correctly represents the relationship between potential difference and a current in a non-ohmic resistor. You should already know this. The non-ohmic resistor has a very specific graph to it. So immediately you should know the answer here to be 10C. However, let's go through why. So the relationship between our potential difference and our current is one that is increasing. However, this straight line increasing is only if it follows Ohm's law, which means it only if it is an ohmic resistor. Whenever it is not an ohmic resistor, a non-ohmic resistor, we know that it always follows this kind of exponential, not directly proportional curve. So 1.10 is C. All right, I hope that makes the multiple choice a little more understandable. And we will now move on to question 2. All right, question 2. Two forces that they've given you of a magnitude 50 and 80. Sorry, let's just draw it out. So 80 newtons and 50 newtons. All right, so two magnitudes on a Cartesian plane are given below. 2.1, give the correct term for the following description. So if they describe a single vector having the same effect as two or more vectors together is, again, learning your definitions is extremely important. You should be able to explain the definition of something as well as give, if they give you the definition, give the word explaining the definition. This definition is explaining a resultant vector. So if something has an effect this way and that way, and the result, the final result, the equation, the sum, or the difference between them is, let's say, that direction, which is less, that is your resultant vector. It is the result of adding or minusing your two vectors together. All right, question 2.2.1 says calculate the magnitude, so magnitude without direction, of the vertical component of the 50 Newton. So they want you to know the vertical component of your vector here. So we are told here initially that this is 30 degrees. So what would our results or our components of that be? So you want your f of y, because this is your y-axis, this is your x. So you want your f of y. That would be equal to your force, which here is 50, so our force, times, if this is our opposite, our adjacent and our hypotenuse, we are trying to figure out our opposite and we have our hypotenuse. So that gives us sine. Because remember, sine is equal to opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Always remember that for maths and for science. All right, so we have opposite and hypotenuse. So you would have sine theta. And now we need to fill in the values we know. So we are trying to calculate our f of y, which is equal to our force, 50 newtons, times sine of our angle, which is 30 degrees. So now if you put that into your calculator, you would get a result of 25 newtons. And remember, in the question they stated magnitude, so you need your units, but you do not need a direction for this question specifically. Now question 2.2.2 tells you to calculate the magnitude of the resultant or net force. So what is the magnitude of our resultant force? Well, we now know that it's 25 to the left, 80 to the right, and something up. But we don't have what our up is. Sorry, it's actually 25 up and we don't have our left. Sorry. So first thing we need to do is to calculate this value here. How would we do that? Exactly the same way we just did, but using now cos. So here we would have to calculate our fx, which would be equal to our force, times our cos of our angle. So f of x would be equal to 50 newtons times cos of 30, which would give us 43,3 newtons. So now we know that here to the left we have 43,3, and to the right we have 80, and up we have 25. So we know that we need to figure out our net in this direction, that plane. So we would say 80 minus 43,3, which would give us a resultant of 36,7 newtons to the right. And why is it to the right? Because our 80 was to the right, and that was our larger force. Now we know that we have 36,7 newtons to the right and 25 newtons upwards. So what is our actual resultant? If you look at it like this, you have 36,7 to the right and you have 25 up. So our resultant would be somewhere in between, going up and going right, somewhere in between. How could we figure this out? Well, if we made this a complete triangle, and it's a right angle triangle, you could use Pythagoras' theorem. So our hypotenuse squared, which would be our f net squared, would be equal to our x component squared plus our y component squared. So our f net squared would be equal to f of x squared, which is our 36,7 squared, plus our f of y squared, which would be 25 squared. And if you put that into a calculator, you should get your f net to equal 44,41 newtons. And now again, they only said magnitude of the resultant force. They did not say the direction, although question 2.2.3 is the direction. So, but for 2.2.2, you just have to leave it like that. But now for 2.2.3, they ask for the direction. How could we determine our direction here? Well, again, let's draw out what we have. So we have our resultant here of 44,41, our x of 36,7, and our y of 25. So how do we figure out our direction? We need to figure out our angle theta over here. So what do we have? You can also write it's the same as 25 here and 36,7 here. So there are various ways you can do this. You can use this triangle using this value and this value, or this value and this value. It just depends on which trigonometric function you use. So if we say sine, or let's choose to use sine. So if we say sine of our theta means our opposite. So our opposite over our hypotenuse. So then we would have 36,7 over 44,41. In your calculator, you would say shift sine, put this in, and you would get a value of 55,74 degrees. Again, like I said, you can use various things. If you wanted to say cos theta, you could say your adjacent, so your 25 over 4,41, put that in your calculator, and you would still get the same answer of 55,74. And again, for tan, you should also get the exact same answer. Remembering to use theta as your answer and not this angle down here. All right, that would be it for question 2. Moving on now to question 3. Just a side note, all of your questions say to start on a new page. So when you are doing it in your exam, please follow those instructions to make the examiners happier and a little kinder when they mark, possibly. And also for their admin, please always just remember to read your instructions and start on a new page. Question 3 says you have a box with a mass of 45 kilograms. This is pulled with a force of 90 newtons at an angle of 50 to the horizontal. The box moves at a constant velocity. What does constant velocity mean? Our acceleration is 0. So, and this is on a flat surface over here. First question, 3.1 says, define the term kinetic frictional force. Again, definitions are so important. There are free marks in your exams. Please, please, please study your definitions. Frictional force is the force that opposes the motion of an object relative to a surface. So remember, your frictional force is the force that goes opposite to the motion. So here you have this going right. So your frictional force will always then oppose the movement of an object. So yeah, it's just the definition. It is the force that opposes the motion of a moving object relative to a surface. Frictional force is always an opposing force. 3.2. State Newton's first law of motion in words. Please, please, please study your definitions. What is Newton's first law? Newton's first law is that a body will remain in the state of rest or motion at a constant velocity unless a non-zero resultant force acts upon it. So this is it's the first law. It is saying that an object will not move unless acted upon by a force. So a body will remain in its state of rest or motion at constant velocity unless acted upon by a non-zero or net force. So there's some more important parts of this and less important parts, but it is important to try get it as close to the exact definition that they give you in your textbooks. People have different ways of saying it, but as long as you get the correct wording and the correct keywords in, you should get your marks. So this one is saying that a object or a body will not move or it will not stop its constant movement unless acted upon by a net or resultant force. All right. Question 3.3. Calculate the magnitude of the horizontal component of the applied force. So we had an applied force of 90 newtons, that direction, at 50 degrees to our horizontal. So they want to figure out the horizontal component. They want this component, horizontal component. So how would we do that? Again, our Fy would be equal to our Fx. Horizontal component. Remember, x here, y here. So sorry. Our f of x, if we go our hypotenuse, our adjacent, and our opposite, we want this horizontal, this x. So we need our cos theta times our force. So we would have f of x is equal to our force times our cos of theta, so 90 times cos 50 is equal to, if you put that into your calculator, 9 times cos, and then in your brackets 50 degrees, you should get 57,85 newtons. And here again, they only ask you for your magnitude, so you do not need a direction. If they did want your direction, it would be to the right. 3.4. In question 3.4, we are now asked to calculate the magnitude of the normal force. So what is our normal force? If we look at our diagram here, our normal force is our upward force here acting on this object. So if we didn't have any applied force, our normal force would be equal to our weight. But since we have this slightly up, this has a x component, a horizontal component, but it also has this y component, which would decrease our normal force. So now we need to calculate our normal force. To calculate our normal force, we would have our normal force is equal to, usually our normal force is equal to our weight. But now, like I said, we already have a slight upward force. And because the object's not moving up, our normal force plus that object will be equal to our weight, if you look at a free body diagram like that. So our weight minus our upward component, our Fy, would give us our normal force. So our normal force is equal to our weight, which is 45 times 9,8, our force of gravity, because remember 45 is our mass, times our gravity to get our weight, minus the component of Fy, which would be our 90 times sine, y sine, because you have your hypotenuse and you want your opposite, so sine 90 times 50 degrees. So if you put that into your calculator, you should get a normal force of 372,06 newtons. Again, they only asked for the magnitude and not the direction. Had they asked for the direction, it would have been up. 3.5. Question 3.5 now says, calculate the coefficient of the kinetic friction. So now we don't have any indication of friction in our question, but they did not say it was a smooth surface, so there is friction. But what important word is given in capital letters once again? Constant velocity. So now when we are looking at our motion, our object is moving to the right. So we are looking at our horizontal motion. What do we know? We have our x component saying 57,85 newtons to the right. And since our acceleration is 0, our F net is therefore, if A is 0, 0, which means our applied, so our F of x minus our friction should be 0, because that is our F net. This F net is the same thing as saying our F of x minus our friction, because you have a applied force going that way, your x component of your applied force going that way, and friction opposes the motion of an object, so we have a frictional force going that way. Therefore, your frictional force is equal to 57,85 newtons. How else, or how else can you calculate friction, or what other equation do you have to calculate friction? You know that your kinetic frictional force is equal to the coefficient of friction times your normal force. And now we have two of the three values. Therefore, we can substitute in. Our 57,85 is equal to, we don't know our coefficient, that's what we're trying to work out, times our normal force, which we calculated to be 372,06 newtons. Divide both sides by 372,06 and you should get your frictional coefficient to equal 0,16. And remember that this makes sense. Our frictional force usually is a smaller number and it has no unit. So there we go. You have your coefficient of your frictional force. Question 3.6 now asks us, will the coefficient of kinetic friction change if the angle of the applied force is decreased? Write yes or no and give a reason. Okay, so they're saying that if the angle of the applied force is decreased, so if we now had our block and our angle came from here and it was now at, call it 20 degrees instead of 50 degrees, what effect would that have on our x component specifically, or our y component and our x component? So if we had now 20 instead of 50, our x component would increase. Specifically, if we put in these values, 20 degrees, we would now have 84 there, and we would have 30 newtons here. So therefore, they're saying that you would have a larger force pulling it to the right and a smaller force upwards. But the question specifically says, will the coefficient of kinetic friction change? And the answer is always no. The coefficient of kinetic friction is not dependent on any other force. The coefficient of kinetic friction is dependent on the surface you're working with. So yes, this will impact this, and this will impact this. Every other part of your equation will be impacted, but this remains the same because that is dependent on the surface, the forces being applied. So the answer for 3.6, no. And then the reason is the coefficient of kinetic friction is dependent on the nature of the surface, or even the type of surface it's on, not the force. And therefore, it will not change if our force changes. So always remember, kinetic friction, we do not have a unit, and it is not dependent on the forces applied to the object it is working to oppose. Moving on now to question 4. Here we are given a graph and a lead-in. So let's read. So learners try and investigate the relationship between the mass of an object and the acceleration it experiences when a constant net force is applied on the object. They use their results to draw a graph such as below. So you're given a graph that looks like this, i.e. indicating a linear or directly proportional relationship with your x over here and your y over here. This y-axis is 1 over a, so meters per second -2 to the -1, and this x over here would be your mass in kilograms. All right, question 4.1 asks us now to state Newton's second law of motion in words. again, you can see how important it is to learn your definitions. So Newton's second law is saying that when a resultant or net force acts on an object, the object will accelerate in the direction of force. The acceleration will be directly proportional to the net force and inversely proportional to the mass of an object. Remember, Newton's second law is basically explaining this equation here. So now let's write in words what this equation is saying. The equation is saying when a net or resultant force acts on an object, so when our net or resultant force acts on an object, the object will accelerate in the direction of the net force. So remember, if we have acceleration in a direction, we will have a net force. If we don't have acceleration, we have a constant velocity, our F net would be 0. But here, when we have a net force, the object will accelerate in the direction of the net force. The acceleration is directly proportional And how do we know that it's directly proportional? We can see that A is directly proportional to F net, because when it is on the same place, on opposite sides of the equal sign, so when it is x is equal to y, that is directly proportional. If x is equal to 1 over y, that is inversely proportional. So our acceleration is directly proportional to the net force, and the acceleration is inversely proportional to the mass. And now, if you look at this, you think, oh no, but the mass is also on the same side as the equal sign. But if you are dealing with your acceleration, this second part is dealing with the acceleration as the focus. So your acceleration is equal to your F net over your mass. So your acceleration is directly proportional to your F net and inversely proportional to your mass. Because if you think about it, it's the same as saying, A over 1 is equal to F net over mass. So these are on the same, they're both the numerator, so those are directly proportional, and that is in the denominator, that's in your numerator, so those are inversely proportional. So that's what the second part is dealing with. And so it's quite a mouthful, but it's not a difficult law to understand. Newton's second law, when a net force acts on an object, the object will accelerate in the direction of the force. The acceleration that will be directly proportional to the net force and will be inversely proportional to the mass of that object. All right, so that's our definition. Question 4.2 asks us to calculate the gradient of the graph. So how could we calculate the gradient of the graph? You could do your change in y over your change in x. So now the easiest way to do this is to look at your graph and find points that fall directly on the lines. What I mean by this is you're given a graph paper with lines like that. And sometimes your graph will go directly through a line over there. And this is much easier to read than, for example, this point over here or this point over here, because then you must estimate where it is over here. But this point over here would be exactly here, which would be a labeled point, and would be exactly here, which would be a labeled point. So it's always best to look on your graph and try find these kinds of points instead of this random point here. But if you do work it out correctly, any 2 points on the graph will work out. So if you're looking at this graph here that you're given in your question paper, I would say that you have quite a nice point through almost every point. It goes through many, many axes. So if you choose any point and you say your change in y, so if we choose the point 2 and we choose the point 1, then you got correlated with your x. The point 2 is also at the point of 1 on your x-axis, and the point of y is equal to 1 is minus 0.5 on your x-axis. So now you can calculate 2 minus 1 is 1. 1 minus 0.5 is 0.5. So 1 divided by 0.5 will give you 2, a gradient of 2. So that would be question 4.2. Question 4.3. And if you do not have this past paper, if you do not have the question paper in front of you, you can go to the government education site and go to 2018. You will find the physics past paper, and the question paper will be there for you. Question 4.3 asks you to determine the net force applied on the object during the experiment. So how would we determine our net force applied? So we have our equation of F net is equal to M times A. So how could we figure this out? Well, we can say that we know our gradient. And what does our gradient represent? Well, our gradient, which was our change in y, so our y over our x, if we use our units, we could say that this is 1 over a over m. So now if you were to switch this around, you could get that it would be the same as saying 1 over a divided by m is the same as saying 1 over a divided by m, which is the same as saying 1 over a times 1 over m. So it would be the same as saying 1 over a m, or ma, to make it look a little bit more like our original equation. So what would that be equal to? If you look here and you look here, it is saying that 1 over F net is equal to 1 over MA. And our 1 over MA, which is our gradient, is 1 over 2. Therefore, F net is equal to 1 over 2, which is equal to 0.5 newtons. There is another option. You could read off of your graph. F net is equal to MA. So off of your graph, you could find a mass. So your graph has mass at the bottom here. So if you chose a point here off of your graph that read, for example, 1, and that correlated here with a 1 over A of 2, you could also substitute that in and you would still get an F net equal to 0.5. All right, question 4.4. It now asks us to write a conclusion for this experiment. So what conclusion can you write from this experiment? Well, you can see that your acceleration would be inversely proportional to the mass of your object. And how can you see that? Well, you can see that this is a directly proportional. So why are they saying indirectly proportional? Well, it is 1 over A that we're dealing with and M. So our mass or our acceleration, since our acceleration is our y-axis, it is our dependent variable. So let's say our acceleration is inversely proportional to the mass of an object. And this is true if F net is kept constant. Because if we look at our formula, it is dependent on F net being constant. So we need this to be constant for this to be correlated by being inversely proportional. So if you look at it in that sense, you can easily see that our acceleration is inversely proportional to our mass. Remember, this would be directly proportional and this is indirectly proportional. 1 over our second variable means inversely proportional. All right. So now we can move on to our question 5. Question 5, we are still dealing with our Newton's laws, where they tell you that you have a slope, an inclined slope at 15 degrees to the horizontal. You have a point here of A, B, and the bottom point here of C. Between B and C, you have a rough patch, i.e. there will be friction. You have a crate of 25 kilograms here at the top of A, and this mass slides down our slope. And during the first part of the motion, there is no friction, so this A to B is smooth, and between part B and C, we have friction because it is rough. These little dots indicate that it becomes rough. Question 5.1. Draw a free body diagram of all the forces acting on the crate while it moves from B to C. Very importantly, while it moves from B to C. What's important between B and C? It is rough. So if we have our object here, always your weight goes straight down. Even if it's on a slope, your weight is acting straight down. So you have your weight straight down. You have, since it's on the rough surface, you have your friction opposing the motion. So which direction would your friction be in? It would be up the slope here. So now we take that and we say up the slope would be your frictional force. And then what other force do we have acting upon here? Whenever we have a weight, we also have our normal force acting upon here. Remember, your normal force is always perpendicular to the contact with the surface. So your normal force is not opposite to your weight. It is perpendicular to the surface here. And then that would be your free body diagram. This weight does have two components, your parallel and your perpendicular component, but you do not have to include those into your free body diagrams. They will be dealt with later. 5.2 asks us to calculate the magnitude of the acceleration of the crate while it moves from A to B. So the magnitude, i.e. you do not need to calculate direction, of the acceleration of a crate while it moves from A to B. While it's moving from A to B, there is no friction. So there is only one force acting to pull it down. And what is that force pulling it down? It is the component of your weight that is pulling it down. So your F net is equal to MA. This is one of the most important equations. You will often need to use it, so always think about it during these kinds of sums. So what components of your weight, so if your weight is acting straight down, you have two components, one going like that and one going like that, to pull your weight down. So we need this component, which is going down. It is pulling our weight down. So we need to figure out what this component is here. We know that the weight here is 25 times 9,8, and we want to determine here. So now we can say our components of weight, there is no friction, remember it is smooth. So our components of weight is our mass times our gravity times our component pulling down is always our sine, And our angle, they told us here, is 15 degrees, which is equal to our mass times our acceleration, which we are trying to determine. So it is our only variable we now do not know. If you put that into your calculator and then divide both sides by 25, you should get that your acceleration is equal to 2,54 meters per second to the negative 2. Do not forget your units here, but they did tell you magnitude, so you do not need a direction. Had they asked you a direction, you could have said down the slope. All right, question 5.3. This question now asks us to calculate the magnitude, write down the direction of the acceleration of the crate while it slows down from B to C. Right, only up the slope or down the slope. All right, so if we had our crate and it was busy sliding down from A to B, and now from C, it's slowing down. It is no longer accelerating that way. It is actually accelerating that way because it is slowing down. The frictional force is making it move slower. So it is actually accelerating up the slope. So it's not moving up the slope, but the net force is going up the slope. Otherwise, it would not be slowing down. So our net force, our F net, is up the slope due to the friction. So our frictional force is currently greater than this component of our gravity because it's slowing down. Its F net the F net is therefore up the slope, and our direction of our acceleration here, as we said in Newton's second law, is the same as this direction here. So if our F net is up the slope because it is slowing down, our acceleration is also up the slope because of our friction. Okay, question 5.4. This now asks us tells us the magnitude of the net acceleration from B to C is 1.2. Calculate the magnitude of the frictional force acting on the crate. Again, our main equation, our F net is equal to M times A. What do we know our F net is equal to? Well, we know our F net is our force, our parallel gravity force, minus our frictional force, which will equal to our mass times our acceleration. So our mass times our acceleration. So our force down the slope, we've already calculated as our 25 times 9,8 times sine 15. So if you already have a value for this force, you may put it in here, but doing it this way without having a value and saying the actual equation gives a more accurate answer, because if your answer has many decimal places and you round it off too early, it could slightly influence your answer. So this is just a slightly more accurate way of doing it. Minus your frictional force, which you are trying to calculate, which should be equal to your mass, 25, and your acceleration. Since we've now made this our positive and minus our frictional force, we have to say our acceleration as a negative number. Now, if we calculate this, put this into your calculator, this, all the minus this, take that across, you should get a value for frictional force to be equal to 93,41 newtons. And that should give you your final frictional force between B and C if your acceleration is at 1.2. And do you see that our acceleration will be larger than this value because it is slowing down. It is accelerating up the slope. It's not moving up the slope, but the acceleration, the net acceleration, is up the slope i.e. our negative here because of this being a negative. I hope that makes sense. Yeah, and that will be it for question 5. We will move on to the last question I will be going through in this explanation, question 6. Alright, question 6.1. Well, let's read our intro. We have a gravitational force on a probe called Curiosity. On the surface of Mars is 3,338 newtons. So the gravitational force exerted on the probe on Mars is 3,338 newtons. The radius of Mars is 3,390 kilometers, and the mass of the planet is 6,39 times 10 to the 23 kilograms. Okay, so we have our gravitational force on the probe on Mars is 3,338 newtons. We have a radius of Mars to be 3,390 kilometers. And we have the mass of the planet to be 6,39 times 10 to the 23 kilograms. State Newton's law of gravitation in universal gravitation in words. Again, the importance of learning your definitions to get these free marks. Okay, so this is also a slightly longer explanation, but basically the universal law of gravitation is that every particle in the universe attracts every other particle with a gravitational force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Again, this is based on an equation. If you know the equation, you can describe the definition, or if you know the definition, you can do the equation. So our equation of the force is equal to the masses over the square of their radius. So each particle in the universe attracts every other particle with a gravitational force that is, and now you use this, proportional. So this force is proportional to this part and inversely proportional to the bottom part. So a force that is proportional to the product of their masses, and by their masses they mean the two objects' masses, and inversely proportional to the square of the radii. Sorry, not the radii, the r, which is the distance between them. Alright, so that is our explanation. And it is according, like I said, to this. The force, each particle in the universe attracts every other particle, so that's the intro, with a gravitational force. The gravitational force that each particle is attracted to one another is proportional to the product, so the timesing of their masses, and inversely proportional to the square of the distances between. Okay, and now we move on to question 6.2. We are asked here to calculate the mass of the probe. So here we can use our formula. F net, or our force, is equal to our gravitational times our mass, 1 mass 2 over our distance squared. So we have our value for G, which is given to us in our questions. And we need to then substitute in everything we have. So our force, we are told, is 3,338, which will be equal to our 6,67 times 10 to the minus 11 our 6,39 times our 10 to the 23, which is our mass given to us, the mass of our planet, and then the mass of the probe, which we are trying to determine. That will all be over the distance between them, which they also told us to be 3,390 times 10 to the 3 squared. So remember to square your distances and change your kilometers into meters. And this is where we get this 10 to the minus 3. It's very important to make sure you use the correct units. So when you write out, it's very helpful to write everything out. This is in kilometers, and so you can times it by 10 to the 3 and get it into meters, which it can then be used for your equations. Now, all you need to do is to put that into your calculator. If you plugged in all of those values, you should get a mass of the probe equal to 900 kilograms. And that would be your answer for question 6.2. Question 6.3 now asks you to calculate the weight of the probe on Earth. So how would the weight of the probe be if it was on Earth instead of on Mars? On Earth, the weight of the probe would be equal to its mass times its gravitational force. So its weight on Earth would be its mass, which we calculated to be 900 kilograms, times what is our gravitational force on Earth, 9,8 meters per second. So our weight would be equal to 8,820 newtons. And that would be your final answer there for 6.3. I hope all of that explanation helped with that part of the exam, and I wish you luck for any exam that you're about to write.